distance. And to get the distance, we use Pythagorean theorem, which is also known as a distance formula. So delta x and delta y, we have to square both of them, and that's going to equal d squared. So this is probably different from what you're used to, but it's a way better way of finding the distance. So the change in x values goes from -5 to -1, so that's a distance of 4 along the number line. Now, the y values go from 3 up to 7, so that's also a distance of 4. So the value of d is going to be 4 squared plus 4 squared square root. So it's going to become the square root of 32, which goes down to 16 and 2, so that's going to be 4 rad 2. So if we're writing out our equation, we'll have, what is it, x minus h squared plus y minus k squared equals r squared. So r squared, by the way, if this is r, then r squared is just 32, isn't it? Because we just square both sides here. Okay. So 32 on the right side. And then h comma k represents the center, and that's -5 comma 3. And so since there's minus signs in the formula, all we have to do is actually just take the opposite of these. So -5 becomes +5, and the 3 becomes -3 here. So there's our equation. Express this as a trinomial. So we just have to FOIL it out. So 2/3 x minus 1. So now I do first, that gives me 4/9 x squared. Then I can do outer, that's minus 2/3 x. Then I can do inner, so I get another minus 2/3 x. And I do last, which gives me a +1. So 4/9 x squared minus 4/3 x, right, because these are like terms, +1. That's kind of it for that. Find the total number of different 12-letter arrangements that can be formed using the word Pennsylvania. Okay, so Pennsylvania 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so it is a 12-letter word. So right away we have 12 factorial for the number of different ways of arranging those. But we have to divide out all the redundancies, which is anytime we have a repeated letter. So P does not repeat, E does not repeat. There are 3 n's. That's going to be a 3 factorial for the arrangements of those n's. Let's see, S, no, Y, no, L does not repeat, V does not repeat. A, there are 2 A's, so we get 2 factorial for that, for the different arrangements of the A's. So that's about it. Now we just have to sort it out. So let's go back to our calculator. 12, and then we go to our math menu, probability, and we go to number 4, 12 factorial, divided by, and then we use parentheses, we'll do 3 factorial, math menu again, probability again, 4, times 2 factorial, 2, again, math menu, probability, and factorial, and close it up and see what that equals. So 399,168,00. 399,168,00. That's our answer. Solve algebraically for x. So x squared minus 9, we can factor, make x plus 3, x minus 3. Get a smaller pen here. So then, let's see, we have 1 over x plus 3 minus 2 over x minus 3 equals 4 over x plus 3, x minus 3. And whoops, I actually switched this. This is actually 3 minus x. Okay. So it would be nice if these matched up, but this one is being a little difficult. It's sort of backwards of how we need it. So what we can do is we can actually absorb this negative sign into the denominator, right? Turning this into a plus, and we have a negative sign here, which then distributes in, right, to make it -3 plus x, and then we can switch them around to make it x minus 3. So we get 1 over x plus 3 plus 2 over x minus 3 equals 4 over x plus 3, x minus 3. Right, so that makes it a little nicer. Now at this point, in order to get these to be common denominators, we just have to write in what's missing, top and bottom. So here we're missing an x minus 3, top and bottom. Here we're missing an x plus 3, top and bottom. And then we distribute in, so x minus 3 here, plus 2x plus 6, and of course I don't need parentheses on this first item here, equals 4. And now at this point I could drop the denominators since they're all equal to each other. So 2x and x makes 3x, and I have here a negative 3 and a positive 6, so 6 minus 3 is 3. And then I can subtract my 3, and 3x is 1, divide by 3, I get x is 1/3. Okay, next, if tan A is 2/3 and sine B is this, angles A and B are in quadrant 1, find the angle of value of tangent of A plus B. Okay. So one way I could do it is find out the angles A and B, and then add them together, and then take the tangent of that. But that's kind of cheap. Well, I'll show you how to do that anyway. So here's the cheapo way. So we'll do an inverse tangent on 2/3. Inverse tangent of 2/3. That'll give me the value of the angle A. Right, so angle A is 33.69. 33.69. So I'm doing an inverse tangent of this entire thing. And then I do the same thing for the other equation. Do an inverse sine on that to get what B is equal to. So I do a second sine of 5 over radical 41. And I get 51.34. Okay, so now I can add A and B. 33.69 plus whatever is there is 85.03. So it's very close to 85 degrees. And I want to do a tangent of that 85.03 degrees. And so I'll do tangent, second answer, equals 11.4998. 11.4998. So I can round this to 11.5, I guess, right? Or even 11.50 if I want to choose this as my pivot. So that's sort of a cheesy way to do it. But if you wanted to see another way, that would be using the tangent of A plus B formula, which calls for these things in it. But yeah, this way is fine. 38. A study shows that 35% of the fish caught had high levels of mercury. Suppose that 10 fish were caught from the lake. Find to the nearest 0.1% the probability that at least 8 of the 10 fish did not contain high levels of mercury. Okay, no problem. So this is a binomial probability question. Binomial because there are two possible outcomes. So we have to define what a success is and what a failure is. So success and failure. So what is going to constitute a success? Well, let's say not having high levels of mercury. Let's call that a success, right? So no mercury. And let's just call this yes mercury. Okay, so the probability of success is denoted by P. So P is going to equal, well, this number here is chances that it does have mercury. So that's going to be Q, 35%. And then 65% will be P. Now, We also need N and R. So N is the number of trials, which is 10 because there's 10 fish caught.